Okay, folks, how's it going? Good morning to everyone. So today we're going to be taking a look at the scientific revolution and talking a bit about that as a review. And scientific revolution is probably one of the easier units in Euro, so I don't suspect that this will take me that long to get through. My guess is it'll probably take me about an hour to get all the way through it. Maybe not even that long. I guess we'll see. Scientific revolution spans a lot of the time period that we've already been learning about in this class. So if you remember that the age of discovery contributed to the scientific revolution significantly. The age of discovery made it so that Europeans started questioning their previously held beliefs about the world. And because there were just indisputable facts that they were presented with, indisputable evidence that people were presented with that forced them to realize that what they thought about the world or their belief system, which was of course primarily rooted in the Roman Catholic Church, was just flat out wrong. And so people knew the earth was round. It's not that people thought that the earth was flat, but they didn't have any idea about the other side of the planet. So I'm going to jump over to my desktop. So you have to understand that folks in this time, folks during this time have, at the start of the scientific revolution, the vast majority of people in Europe have a very, very primitive understanding of really anything to do with science, or what we would take today as being common knowledge, quote unquote, which is really a terrible word. Common knowledge, you'll find, isn't so common. Or common sense isn't so common either. So I really try to avoid using those phrases, but I think it's pretty common knowledge these days that the earth is round, and I think that it's pretty common knowledge that the earth revolves around the sun. But these are not common knowledge in a medieval time. They have a very, very, very religious, primarily religious lens through which they understand the world. And there are people in modern society who still interpret the vast majority of their lives through a religious lens. It's not saying that that's gone away completely, but I think that largely we, in the education system, try to promote scientific thinking rather than religious thinking to govern our understanding of the universe. But back in the olden times, that wasn't the case. And remember that most education was tied up in the church itself. So any sort of education that anyone would have received would have been a theological education, not one that's based in, say, like today, the liberal arts. Although we do start to see that change with the Florentine school and the Florentine Academy and the Renaissance. So political theory at this time is based on divine right, the idea that God gains the ability to, kings gain the ability to rule through God. And superstition plays a significant role in the average European person's mindset. They live in a world that is primarily understood by way of means of divinity. Get down. By way of means of divinity interfering in day-to-day occurrences. What do I mean by that? Basically, God inflicting all sorts of things, whether it be plagues or fires or illness or just in general answering prayers or causing grief. That's pretty much what people view as being the determinant factor of what happens. Is like, well, what did God want for things to happen today? There's also a lot of superstition surrounding things like witches during this time. Now, don't get me wrong, because I think that a lot of the witchcraft craze has less to do with it has something to do with religion, but it also has other things to do with social practices between humans, and it also has to do with sexuality, and it also has to do with um, you know like gender roles, I guess, for lack of a better way of putting it. Just the idea of patriarchy in general contributes significantly to the witchcraft craze of the mid 1600s or early 1600s. But scientific thought in the early 1500s was still largely absent in the average European mindset. And we've talked about this PowerPoint. I'm not going to lecture on the whole PowerPoint again, but I'm just trying to set the stage for you. At the start of the scientific revolution, you know, if you were to get a DBQ about describing the scientific revolution as, say, a turning point or something, you would want to be able to point to things that were going on before the scientific revolution, and then explain how the scientific revolution either continued old practices or changed old practices. So one of the things that we definitely see as causes of the this would be more for a causation prompt now for this next part. Causes of the scientific revolution, well, certainly medieval universities had a role that they played. There's kind of a sort of branch of philosophy, or just in general philosophy of philosophy, if that makes any sense, because I don't know if I mentioned this in class before, but to this day you can have a PhD, which is a doctor of philosophy in history, or you can have a PhD, a doctor of philosophy in math, or you can have a doctor of philosophy in physics, or whatever, literature. There's all sorts of different PhDs. Back in the olden days, they developed philosophy as its own accepted discipline, which was probably largely inspired by the ancient Greco-Roman times. And these medieval philosophers developed somewhat of an independent level of independence from theologians, which are religious scholars. So there's kind of starting to be more of a sense of free inquiry. This is prior to the Protestant Reformation, remember. The Catholic Church kind of cracked down on free inquiry after the Protestant Reformation. Leading universities established professorships of mathematics, astronomy, physics within their departments of philosophy. So like I say, when we think about different departments of universities at that time, each of them were considered their own philosophical subject of astronomy or physics rather than scientific subject, right? Because philosophically people had different opinions on issues of astronomy and physics in those days before there were set rules or methods to collect evidence as promoted by the scientific revolution. Major scientific figures usually taught at universities or studied at universities. The Renaissance definitely played its role in contributing to the scientific revolution because of the discovery of ancient math. Remember that for a long time medieval Europe had basically not even really been able to do quite simple math. They're living in a time where the most advanced math was being done by the Ottoman Empire, actually, at that time. And so simple math, simple things in Europe were really not understood that well until the Renaissance, which forces people to start looking at perspective and geometry and math again. A lot of these techniques, of course, rediscovered after the Ottomans had traded back all of that ancient Greco-Roman art and architecture and sculptures and so on to the Europeans. Navigational problems on sea voyages in the age of overseas expansion also created the need for scientific advances because you needed more advanced techniques to navigate, determine your position on Earth's surface and so on. And then finally, scientific methodology developed under Bacon and Descartes, who weren't collaborating together. They lived in different places and lived at different times to a degree. They were contemporaries of one another, but Bacon and Descartes contributed each in their own way to the development of the scientific revolution. So excuse me, the scientific method. So the scientific revolution became the major cause for basically the new worldview. So an old worldview versus new worldview. So old worldview, you explain things through superstition, through mysticism, through divinity, through the church, through scripture. The new worldview is you explain things through known, predictable laws of nature. Radical secularism starts to emerge at this time, and many of the more educated population became openly hostile towards religion, although that development happens typically a little bit later on. We don't really see that level of hostility till like Baruch de Spinoza, who was a dogged, I guess, atheist. The revolution in learning became definitely a major foundation for Western society, and all kicks off with this guy, Nicholas Copernicus. You probably remember him. You may remember the little thing that I gave you guys, cops eat great big, what is it? Cops eat great big donuts now. Now I can't even remember. I'm a little tired today. I didn't sleep particularly well last night. I was up late lecturing, and then I just couldn't sleep very well. Cops bring kids great big donuts now. That's what it is. Cops bring kids great big donuts now. That's the next part of what we're going to be talking about. So just as a reminder of what these guys did, Copernicus, heliocentric view. Previously, people thought that the Earth was a stationary fixed object in the sky, and that all celestial bodies, including stars and constellations and planets and our own sun and the moon and everything, just revolved around Earth. So heliocentric view, the sun is the center of the universe, and it's seemingly more accurate, although not perfectly accurate. You're going to look at this and realize that this is not exactly right, but this was where Copernicus wrote the original prediction of what he believed was the makeup of our solar system. Now keep in mind, at that point they did not yet, you see Saturn here, so this is the sun in the center, and then you have Mercury, Venus, and then Earth with the moon orbiting around it. So here's Earth, Terra, and then the moon orbiting around it. And we go to Mars, Jupiter, Saturn. There's no Uranus, there's no Pluto, and there's no Neptune. And the reason for that is because they hadn't been discovered yet. They didn't have powerful enough telescopes or optics at that time to be able to see that distantly. And then the last ring here was demonstrating the fixed immobile stars around the solar system. Now of course that's not how it works, but they didn't know that back in that time. Seemingly the stars were stationary, which at the distance that they are, of course seems like they are, and then Earth is kind of wobbling and moving, and that's what makes the stars appear to move across the sky. So this is his prediction. There's a couple things wrong with this. Obviously it's not to scale. That's one thing. Number two, the orbits are not circular, they're elliptical. So it's if you're looking top down, it wouldn't be perfect circular orbits, it would be elliptical orbits. Copernican view gets admonished by the Protestant Reformation. Catholic Church didn't initially always interpret the Bible literally, so they weren't exactly upset by Copernicus right away, but by the time that the 17th century rolls around, they proclaim the Copernican view of the universe to be false. Tycho Brahe, or Tycho Brahe, you probably know him. He was the one who I told you died because he thought it was rude to excuse himself to use the restroom, and he ended up causing his own bladder to rupture, which caused a major infection and ultimately resulted in his death a few weeks later. So Tycho Brahe was Europe's best astronomer in the late early 1600s, and he had built the best observatory in Europe and collected data in Denmark. And so he has this massive quadrant here that was quite large, and it allowed him to derive very accurate measurements. Now, ironically, of course, Tycho Brahe is Protestant. He's Dutch, or Danish rather. And so, because he's Danish and because he's Protestant, he does not accept the Copernican worldview, because remember, Protestants came out very early on and admonished the scientific revolution. So Tycho Brahe was trying desperately to collect the data to demonstrate that the world was, in fact, in the middle of the universe. But of course, his data did not show that, and he could not figure it out, in part because he didn't have the right math either. And that's when Johannes Kepler comes in, his protege, his student. So he's another first great Protestant scientist. He's the assistant to Brahe, and he mathematically proved heliocentric universe. Ironically, using the exact same data that Brahe had been trying to use to demonstrate exactly the opposite. He comes up with the 3 laws of planetary motion, saying that orbits are elliptical, planets don't move at uniform speeds in their orbits, they change speed as they revolve around the sun, and then the time it takes for a planet to orbit the sun is going to be directly based on how far away it is from the sun. So this is Kepler's edifice of astronomy, located on the frontispiece to his 1623 Rudolphine tables. And then we get to Galileo, who was the first to use the telescope, the improved telescope, his improved design. Technically, the telescope wasn't invented by Galileo, he simply improved upon it. And Galileo develops the laws of motion using the experimental method of understanding acceleration and inertia in movement. And so the idea being that the more mass an object has, the more energy it takes for that object to move. And then once it is moving, it is going to have a difficult time stopping. It's going to take more energy to change the direction or course of the movement of that object. So Galileo's use of the telescope demonstrated that the moon was also not smooth, which previously people thought it was smooth, but it's actually a rocky surface. Galileo's findings became controversial. He was in Italy. Galileo was Catholic, and he gets sentenced to house arrest, which I saw a meme about this, actually, ironically, yesterday, talking about house arrest and how people are freaking out about coronavirus affecting the economy and complaining about house arrest, and then the meme said something to the effect of, if you think you're frustrated, imagine supporting the idea that the sun was in the center of the universe and then having the Catholic Church put you on house arrest until you died, or something like that. Francis Bacon is the next major figure we're going to talk about. So Bacon, Francis Bacon formalized empiricism, which is the idea of collecting evidence for understanding natural laws or demonstrating relationships between things. And so he used something called the inductive method, which is renounce notions and begin to form an acquaintance with things. And that saying there pretty well encapsulates what Bacon does. There's 2 different kinds of methods here. The inductive method is start with nothing and collect evidence. It's empirical data, right? That's where we get that term empiricism, is to collect data, right? So you start with nothing, renounce what you believe about things, leave it all behind, and then start with nothing, and then just go where the data takes you. But then be careful about the data and don't even trust that, and that's why you got to do it over and over and over again. It's the scientific method. So that's the inductive method. That's one side of the scientific method, formalized by Bacon. Collect evidence to demonstrate understandings of things, and then René Descartes, the other half, which is the deductive method. Deductive method. Cogito ergo sum, I think therefore I am. Remember, his method was start with everything and then one by one, essentially um, eliminate things that don't fit uh, using rational thinking. So this basically he comes up with this idea of Cartesian dualism, which is the idea that the mind and the body are in fact separate entities that may influence one another but are separate from one another. So between those two things, inductive and deductive method, you have the modern scientific method. And then you got Newton here. And Isaac Newton integrated astronomy of Copernicus and Kepler with the physics of Galileo into an overarching theory on how the universe works. So when we talk about Isaac Newton, he's the one who wrote Principia, which is arguably the most important book that almost never got made, thanks to the History of Fish by Willoughby, making the Royal Society go bankrupt. The Royal Society of London was who financed the major thinkers of the time's publications, and so Principia is the most important book about physics to be released for about 300 years until Albert Einstein's theory of relativity is introduced. Came up with the principle of universal gravitation, basically gravity dictating the forces between objects in the universe. Detailed in Mathematical Principles of Natural Philosophy of 1687, more popularly known as Principia. Everybody in the universe attracts every other body in the universe in a precise mathematical relationship. So the larger the body, the larger the mass of that body, the more mass, the more gravity. So if you take Earth and compare its gravity to Jupiter, which has a mass multiple times Earth, the gravity of Jupiter is much greater than that of Earth, and then the gravity of the Sun is much greater than that of Jupiter. Since these are natural laws and unchangeable and predictable, God's active participation in the natural world became less and less needed during a scientific thinking era to explain the forces of nature or why things happen in the universe. And these ideas, of course, became the basis later on for deism, which is I guess you could call it philosophical or religious arm of the Enlightenment. It's not really a religion, but deism was the idea that there was probably a divine creator at some point, but then when things were created after that, the universe kind of just ticked on its own according to these known laws that governed existence. So there's that memory device. Copernicus, Brahe, Kepler, Galileo, Bacon, Descartes, Newton. Those are the big idea thinkers from the scientific revolution who you would probably want to be able to know what they did. Then we start to see also, it's not just about astronomy and physics, it's also about anatomy and physiology as well. We start to see people looking closer at the human body and see the beginnings of understanding human anatomy in a way that makes more sense, at least, to what we know today. Remember that medicine is very slow to develop. A lot of people want to include talking about medical advances in the scientific revolution, but it's not really modern medicine that we're talking about. We're simply talking about anatomy, understanding the body itself. It's really hard to understand medicine until you understand what the body does, right? So keep that in mind, all right? We don't really see modern medicine develop until the 20th century, to be honest with you. Last century, in other words. Modern medicine is pretty weak for a very long time. We don't see the development of antibiotics, for example, until about 90 years ago, which isn't that long when you think about it. Vesalius wrote The Structure of the Human Body in 1543, which of course renewed and modernized human anatomy in terms of people's understanding. The other thing too that you got to remember is this was also inspired by the Renaissance, because the Renaissance put a renewed interest on the perfectibility of man and proportionality of the human body and beauty and things like that. And this starts to challenge Greco-Roman medical views, especially the views of Galen. Remember, just in the same way that Copernicus had challenged the views of Ptolemy, the Ptolemaic view of the universe, or geocentric view of the universe, gets challenged by Copernicus's view. I don't know if I just said Copernicus ago. I might have said Isaac Newton accidentally, but if I said Newton, I meant Copernicus's view of the universe, and that is similar to the way that Vesalius challenges Galen's ancient understandings. Also, we start to see looking at different organs of the body, the heart, the lungs, the vascular system, or the circulatory system. So circulation of blood, William Harvey explained how the heart pumps blood throughout the body. And then Anton van Leeuwenhoek, who came up with microscopy. So another part of the scientific revolution is kind of a technological side of it. And I mean primitive technologies like telescopes and microscopes and other instruments that became used. And Leeuwenhoek wrote about microorganisms in water and the circulation of blood, corpuscles and capillaries. Royal scientific societies, many places in Europe started to develop these in the 15 and 1600s. Governments encouraged scientific inquiry because they wanted to be at the cutting edge of technology, right? So they wanted to learn more. Governments were looking to discover new things, to understand new things, and to give an edge in the global scheme. And scientists could now communicate with each other internationally via these societies. Now, there are some differences between these societies, but we see them established in Russia by Peter the Great, who we talked about last time, Prussia by Frederick I, France, and even in Napoli in Italy. But the most successful probably would have to be the Royal Society, because that was the one that ended up publishing works of like Bacon and Newton and things. So consequences, what are some outcomes of the scientific revolution? Well, of course, it leads to the Enlightenment. We see improvements in exploration. John Harrison's chronometer gave mariners now the ability to determine not just the latitude position, but now the longitudinal position on Earth. So how far east or west they were of the prime meridian. We also see experimentation help to accelerate the agricultural revolution. So the scientific revolution contributes to agriculture, where we start to see new technologies to drain marshy swamplands and build polders and develop more advanced irrigation systems and so on and so forth. So scientific revolution has some very practical means in terms of the agricultural revolution. Also, of course, we see the agricultural revolution comes with it a number of new inventions, right? So we have new inventions, which we'll talk about when we get there, but new inventions like the gosh, I'm totally blanking right now on the name of it. The seed drill, Jethro Tull seed drill, and then well, eventually we see things develop like McCormick Reaper and the steel plow, and but also crop rotation, if you want to include that as a scientific development, and then eventually down the line we'll get to things like fertilizers and so on, but that takes a while before we see the development of those kinds of things. This scientific revolution also contributes in medical knowledge, but I caution you with that, because medical knowledge, we're talking more about anatomy, and there are some medical advances in the 17 and 1800s, but remember that we're still in the 15 and 1600s. I would prefer of you to think of the scientific revolution as a 15 and 1600s thing. Leave the 17 and 1800s to the Enlightenment and the Industrial Revolution. But of course, we do later on see the development of modern alchemy, which turns into chemistry, and figures like Marie Curie and Max Planck with physics and so on and so forth. But again, they come later on. So This also contributes to the end of witch hunts at this time. So witch hunts started to die out after the scientific revolution, and science and religion really don't become in direct acute conflict with one another until the 18th and 19th century, where the church increasingly is feeling threatened by the development of a secular society and public education. So that brings us to the Enlightenment, which we'll talk about on a different day. Today's lesson's pretty short because scientific revolution is pretty short, and so I'm actually going to cut it short here for a Wednesday, and we will pick it up talking about the Enlightenment later on. And so I will put a folder on Schoology that will have an assignment. It'll just be another, I think it's just easiest to keep it doing these little quizzes things, especially in light of the fact that you have some other more thorough assignments kind of in the works right now. So I'm just going to keep it short and simple, short and sweet with these quizzes assignments, and gives you an opportunity to make some points up in the class and stuff like that. So, all right, folks, well, I appreciate you tuning in early on a Wednesday morning here, and we will pick it up on Friday talking about the Enlightenment. Have a great day.